I'm Carol Chin. I'm a conservation scientist at the National Center for Preservation Technology and Training. And I've been doing some work with my colleagues here on the Gulf oil spill and conservation of some cultural resources down along the coast. So today I'm going to be talking about oil and cultural resources, lessons learned from recent oil spills. So first I'm going to talk a little bit about properties of crude oil. This diagram shows the sulfur content, which is characterized on the axis on the left between sour and sweet. So when it's classified as sour, the sulfur content is higher. Sweet crude oils have a lower sulfur content. On the bottom is what's called the API, or American Petroleum Institute, gravity, which is a measure of crude oil density. It's actually the inverse of density, the way it's calculated. So smaller numbers are more dense or heavier. Big numbers are less dense or lighter. And for reference, an API gravity of about 10 is about where water would fall on the graph. So that's actually off the scale for the graph I'm showing you. But for crude oils that are classified lower than 10, they have a higher density than water, and they will actually sink in water. So everything that I'm showing you on this graph is lighter than water and should float on water. And just for reference, you see the blue dot near the bottom that says United States LLS. That stands for Louisiana Light Sweet. That's a sweet crude oil, and that's the same kind of oil that was spilled during the Gulf oil spill. So common oil contamination sources, offshore, nearshore, and terrestrial spills. And by offshore, I mean spills that occur on the continental shelf and slope, so not along the shoreline. Nearshore spills are on the shoreline. Usually they're harbors and ports or storage tanks that are actually on the shoreline. And then terrestrial spills, which can occur anywhere on land, pipeline ruptures, rail accidents, any kind of transportation oil spill. If we look at the recent spills that have occurred within the last 3 or 4 years, these are the ones that are highlighted here. Offshore spill, such as the Gulf of Mexico oil spill, and that was a drilling or production platform. Nearshore spills, Superstorm Sandy caused a tank failure in New York, New Jersey area, and a coastal storage tank failed and leaked. And then you can see that there are quite a few terrestrial oil spills. Pipeline ruptures in Utah, Montana, Michigan, and Arkansas, and a rail accident in Minnesota. So this is one of those. This is the Pegasus pipeline oil spill in Mayflower, Arkansas. During this spill, there are about 5,000 barrels or 210,000 gallons that were spilled. This was a Canadian heavy crude oil. You can see here that it affected a neighborhood. The blue, red, and green trucks are actually vacuum trucks that are trying to recover the oil by vacuum. You can also see all the white booms and absorbent pads that have been placed so that it prevents the oil from contaminating people's homes. So often these oil spills occur in sort of isolated areas. This pipeline happened to pass by this neighborhood and contaminated this neighborhood pretty severely. This next one is in Minnesota, Canadian Pacific Railway spill near Parker's Prairie, Minnesota. You can see this was in the spring. There's still snow on the ground. This oil was a heavy Canadian crude oil, and so it was already pretty viscous. Because of the temperature at the time, it became even more viscous, and so while the spill didn't proceed very quickly, it was very difficult for them to recover the oil by their usual methods. The usual methods are by vacuum, and so when something's very viscous, it's difficult to vacuum it up. You can see the generators and vacuum pumps there in the center of the photo. All right, during Superstorm Sandy, some crude oil, some diesel oil, and some biodiesel spilled into the Staten Island area. Here you see the response team trying to recover some of that oil. You can see the yellow booms. The folks over on the dock are actually completely outfitted for exposure. Those on the ship here or on the little boat don't have all that gear on because they're less likely to be contaminated. They're probably just doing some water testing, while the folks on the other side are actually trying to recover some of the oil. All right, this next one is the Silvertip pipeline oil spill. This occurred on the Yellowstone River in Montana. This occurred when flooding on the Yellowstone River undermined some of the material that was supposed to protect the pipeline from erosion. The pipeline runs under the Yellowstone River, so when it ruptured, it sent oil downriver as far as 70 miles downstream and passed through both large and small communities in eastern Montana, including the city of Billings, but it also passed by Pompey's Pillar National Monument, which is right along the river. It's actually been eroded by the river, and it's where William Clark of the Lewis and Clark expedition carved his name in July of 1806. So they were concerned about contamination of that site. After traveling that distance, I don't think the oil actually contaminated that site. The signature is way up on the pillar, which is a sort of sandstone bluff, and so I think that part of the monument was fine. The shoreline was contaminated a bit. But here you see booms along the Yellowstone River. About 63,000 gallons from ExxonMobil pipeline were spilled during this incident. The next one is the Kalamazoo River, or the Enbridge oil spill. This is Morrow Lake in Michigan. Oil spilled here was more dense than water. It was one of those heavy crude oils, and so the watercraft that you see out there are actually trying to refloat the oil so that they can recover it, because the heavier oil is heavier than water and has actually sunk to the bottom of Morrow Lake. Here, about 19,000 barrels were spilled. These oils are very heavy because they're tar sands oils. So this creates another challenge for recovering spilled oil, is when it's denser than water and you have to try to refloat it to recover it. And then, of course, the Deepwater Horizon oil spill in the Gulf of Mexico. This is the Deepwater Horizon oil rig. This is the largest oil spill in U.S. history, 4.9 million barrels, or 210 million U.S. gallons of sweet crude oil were spilled during this incident. The oil reached shorelines along the coast in June of 2010, and some of the results of NCPT's work will be discussed later in my presentation. So a little bit about oil spill jurisdiction, which federal agencies have jurisdictions at what times. In terms of oil spill prevention and preparedness, it's fairly complicated. If you are looking at preventing spills from vessels or from ships that are carrying crude oil, the U.S. Coast Guard has jurisdiction. If it's onshore and it's not a transportation facility, then it's the Environmental Protection Agency. If it's onshore but it is a transportation facility, then it's the U.S. Coast Guard and the Department of Transportation, which of course makes sense. For deep water ports, again, it's U.S. Coast Guard and Department of Transportation. If it is an offshore facility and its production activities, so oil and gas extraction, then it's the Bureau of Ocean Energy Management. And if it is pipelines that are associated with production, not transportation, then it's also Bureau of Ocean Energy Management. Pipelines that are transporting or transmission lines. Then it's the Office of Pipeline Safety with the Department of Transportation. And then inland pipelines, any terrestrial pipelines, are Office of Pipeline Safety. So that's just for the oil prevention and preparedness. So these folks try to make sure that oil spills don't occur. Once an oil spill has occurred and we go into response activities, thankfully it's much simplified. So in coastal waters, it's the U.S. Coast Guard with support from the National Oceanic and Atmospheric Administration, or NOAA. Inland spills are the Environmental Protection Agency. So NOAA provides support to the U.S. Coast Guard because NOAA also employs scientists and researchers so they can provide guidance in the response activities based on data that they are collecting at the time. All right, in terms of response activities, personal safety is always the most important thing. You can see here that this gentleman is completely outfitted for prevention of exposure to crude oil. A lot of the crude oils have volatile organic compounds that can penetrate the skin or can be easily inhaled and make you feel ill. So you can see that he's got boots, a complete coverall, gloves, a hard hat, and a respirator, and of course eye protection to make sure that he prevents any exposure either to the volatile organic compounds that he can inhale or anything that might come in contact with his skin. This is a photo of the gear that we took when we went to Grand Terre Island to Fort Livingston to do some work out there. You can see our sampling gear. You can see 2 large jugs of water that we took both to make sure we stayed hydrated and also for some of our cleaning tests. The big white cooler, the only thing in there is Gatorade and water, and that was provided by the response support out there at the coast to make sure that we stayed hydrated and didn't have effects from the heat. So hydration is very important when you're working in a hot environment. This was middle of summer when we were out there. This photo is from the Mayflower spill. The Mayflower spill in Arkansas occurred close to a school. So this photo is taken inside a school where their EPA is monitoring volatile organic compounds in the air. So that's a monitoring device that he's holding there. So obviously the school is not occupied at this time. They had to evacuate the neighborhood and the school for a while. We also want to protect our resources from contamination, natural resources and cultural resources. In this case, you can see some yellow booms that are protecting a cemetery from contamination. So physical barriers include booms, berms, sandbags, portable dams, and as you saw in one of the earlier photos, sorbent pads or sorbent sheets. Physical barriers are used most often and are recommended because they don't alter the resources. So they actually sit adjacent to the resources, they keep oil from contaminating the resources, and then they are collected and disposed of according to regulations. So you don't have to alter or risk damaging your resources if you use a physical barrier such as these. This photo shows U.S. Fish and Wildlife Service creating a sand berm, another type of physical barrier to protect a national wildlife refuge from crude oil in Mobile Bay during the Gulf oil spill. And you can see, based on the scale of the tractor, how big this berm is to make sure that the high tide doesn't bring oil onto that refuge. Another way of deploying a physical barrier is by helicopter. And here you can see the Louisiana National Guard deploying large sandbags. The sandbags weigh about 3,000 to 5,000 pounds each, and they're being deployed into an inlet, which is narrow passage between barrier islands down there along the Louisiana Gulf Coast, that prevents oil from entering the bay during high tide. And you can see it's going to take quite a few trips to deploy enough of those sandbags to block that inlet. This photo shows New Harbor Island, Louisiana, which includes a sensitive ecosystem, and it's being protected by a set of booms. You can see the black one on the outside, the orange one on the inside, and you can see in the distance another smaller island that also has an orange boom around it. So these booms are meant to keep oil from reaching those islands and reaching those areas where there are sensitive natural resources. So one of the other things to consider when working in response to an oil spill is to avoid secondary contamination. This means that responders have to be trained so they don't inadvertently cause any additional damage or contamination. You always need to be thinking about protecting the area from sightseers who may have good intentions but may inadvertently cause additional contamination just by walking through contaminated areas and tracking oil onto other sites. This photo shows one of the walls at Fort Livingston where we assume somebody had gotten some of the oil onto their hand, and rather than wiping it off onto a towel or a rag or onto their clothing or something, they decided to wipe it off onto the tabby walls inside the fort. So unfortunate. This photo shows some additional secondary contamination where people have walked through the oil-contaminated areas, and then their boot marks are on the stair treads. So they've transferred oil from their boots onto the stair treads. In most response areas where an official response team is there are cleaning stations set up. This is an example of one. These are simply kiddie pools where boots are cleaned before someone moves on to an uncontaminated area. And you can see the on-site coordinator here doing his due diligence and cleaning his boots before he moves on. You can see all the sorbent pads that are used to pick up some of the excess oil that's also on their boots. And usually there's somebody who helps you at these cleaning stations to make sure that your boots are clean and you're not contaminating other areas with oil transferred by your boots. So on to some of our cleaning tests. This shows one of the areas that we did some cleaning tests on the bricks at Fort Livingston. The spray bottle is how we applied the cleaner. We used a soft bristle brush. We applied some of the cleaner. We let it sit for a minute or two, reapplied, agitated with the soft bristle brush, and then rinsed. So one of the things to consider is when you're at a site, evaluate and document everything. Make sure that you have good photographic documentation, but you should also be taking notes. Take notes about where your photographs are taken, and take notes about the conditions that you see on the site. And you can see here one of the archaeologists who was there with us taking notes in her field notebook. What we learned from our experience at Fort Livingston was clean as soon as feasible. There was a lot of debate about whether we should clean immediately or whether we should wait until all the series of contamination events occur. Every storm during the summer we thought would bring additional oil to the site, and we initially thought that it was best to clean once and subject the site to just one cleaning rather than doing multiple cleanings, which had the potential to damage the materials, even just a little bit. But we learned that it's, especially in the heat in Louisiana, it's really important to clean as soon as possible and then take the risk that the site is contaminated again. Here you see from June 2010, which was our first visit to Fort Livingston, one of the pillars that was contaminated. This oil probably arrived on site 2 weeks before we got to it. And this is shortly after cleaning, or immediately after cleaning. So you can see that most of the oil came off. Most of the darkened area is just wet from us rinsing it. And after it dried, there was probably just a little bit of residue of the oil. We could have done multiple cleanings to make sure we got most of it off. It's very difficult to get all of the oil off, but you can see that the cleaning job was pretty good at this point when the oil was still fresh. When we went back in September of 2010, we chose a site that had not been cleaned before, and we did some cleaning tests, and you can see each of the bricks had a different cleaner used, and none of those are as clean as that initial cleaning test that we did in June of 2010. So the oil at this point had lost most of its volatiles. It was much more viscous. Some of it we could probably have scraped off with a plastic spatula, but most of it was adhered pretty tightly to the brick at this point, and pretty waxy and sticky. So it was very hard to get off with the same cleaners that we used in June. And then we went back again in July of 2011, and we used a series of different cleaners. We also used a poultice. So we applied the usual way by spraying and agitating with a soft brush. We also applied cleaners by mixing the cleaner with a clay poultice, applying that, leaving it overnight, and then going back the next day and cleaning it off. And here you can see the results. So we did just sort of a control with water, sand, and clay. That's just water and sand and some of the clay that we brought from the site that we just placed on there and used that as a poultice. The other ones, the Gugon spray gel, the methanol, the CitraClean, the Shout Advanced, and Marine Green Clean were all applied with a clay poultice that we brought with us. So they were mixed up to the consistency of peanut butter, applied, spread on evenly, and covered so they would dry slowly overnight and removed the next day. The spray agitate samples on the right were all, the cleaners were all applied the usual way by spraying with a spray bottle, allowing it to sit for a few minutes, reapplying, agitating with a soft brush, and then rinsing. And you can see that some of the poultice samples worked very well compared to the spray methods, but of course the poultice method is more time consuming and uses much more materials. So it really depends on how much area there is to clean and what kind of resources are available to fund the cleaning. So in terms of the materials, we always have to consider whether to clean right away, whether to wait and clean once, what that will do to our materials. And for brick and mortar structures such as Fort Livingston, they're all porous materials and they tend to absorb the oil very readily. We suggest cleaning because the microbes that digest the oil, naturally occurring microbes, tend to produce acids during that digestion process, and those acids can attack the brick and mortar and cause more deterioration. So it's important to clean a site that's contaminated as soon as possible or as soon as feasible. And if you're using a cleaner that, some of the cleaners we used were solvent-based, and they tend to leave a little bit of a residue. For those, they usually require secondary cleaning with a surfactant-based cleaner to remove any of those solvent residues. So this was a shot from the fall of 2012 after one of the storms that came through that fall. And you can see along the barrier, this is a view of Fort Livingston, you can see along the barrier that oil that had been buried over the past few years was brought back up to the surface, and you can see the riprap is contaminated with some of the oil there. So cleaning is going to be an ongoing process. This was, I believe, after Hurricane Isaac, and the beaches of Grand Isle also had oil re-exposed there, and they did an additional cleanup after Hurricane Isaac along Grand Isle as well. So just some acknowledgments. Louisiana Office of State Parks invited us several times to go out to Fort Livingston, so thank you to everyone there. They also accompanied us and helped us while we were there. Unified Area Command, part of the response effort, also assisted us and invited us out to conduct our research. Vessel of Opportunity Program. These folks were great. They supported us while we were out there. They transported us out to Fort Livingston. And in one case, they actually provided us with an additional cleaner to test. Consultants, Sarah Clowery and Courtney Cloy, accompanied us as BP representatives. Payal Vora at UT Austin did some research out there as part of her master's thesis, and then my colleagues at NCPTT who also accompanied us out into the field. So thank you all, and if you have any questions, please let me know. And for more information, here is my email address. Thanks.